experiments happening in here. Maybe we'll do another episode about those sometime after it's not top secret anymore. All right, but back to our experiment of what is in my teapot.
Okay, so we will start with these. So which is, or you want to start?
Yeah, this is good. So this is the one that's supposedly pewter.
Yeah. So we could just put it here or this way, the way that has better contrast. I think that should work.
Okay.
So then, so it just now I click here, and the process will start. It will be like 10 seconds. So we'll end up having the spectrum here.
Okay, so yeah, so 10 seconds. So that's how long it's taking for the signal.
So I started now.
Okay, cool.
And then we already see we can go a little longer to be a better
to build signal.
Signal. So and to have enough statistics. So after some minute, you can do longer. So, but I think 10 seconds even now.
Yeah, I don't see it changing anymore, so I think we've got our answer.
So now, the next step is to find out, we are generating these peaks, to find out what those peaks are. So we have this, let's say, go to this periodic table here, and this technique has some limitations. So it cannot detect elements lighter than sodium. You could start with magnesium. So then we are just comparing the possible spectra with known our spectra with known elemental spectra. So this peak looks like copper. Yeah, it says copper 3 alpha, which is copper X-rays emitted at secondary X-rays. So then we can add this. So these two peaks are copper. Okay. So now, and another possibility, we have some very small amount of nickel, but that's not conclusive because the setup itself also that part has some small amount of nickel. So
okay, so it might be finding nickel from the machine instead of from my teapot. But that's okay. I'm okay with drinking out of a nickel teapot. That's fine.
I don't think it's there. It's rather a machine.
Okay.
So then we will search the other peaks.
Right. So we're also looking.
This one is tin.
Tin. Okay. I thought you were going to say lead.
No, lead.
Okay, good. Tin. But tin is.
There is no lead, so that should be here. So.
Oh, okay.
So for this, do you need to just know where all the elements are? You just you're guessing and checking.
So you don't need to guess. So you just check it. So you basically guess in the way that you know that it's written as pewter. So you know you Google it and find out possible elements and guess. But so now if we go to lead, so which is here. So you see. Might be very small possibility having some lead.
Oh yeah.
Maybe, but it's not much. So we do have small amount of lead.
And you're sure that's lead and not antimony? Is there any other thing that could make peaks at those energies?
Antimony should be here. It's not. Let's see.
What about silver?
Let's check silver before. Silver is bigger peaks. Yeah, there's no silver there. And that's mostly lead, very small amount of lead.
Okay.
Okay. So
and what about bismuth?
We'll check this. And then we can remove bismuth.
No bismuth. All right. Well, Google thinks pewter has bismuth, but not this pewter. This pewter has copper, tin, and lead.
Yeah, there would be some more minor elements, but that's basically it. So mostly we analyze as it's copper, the significant quantity of tin, copper, to a very small amount of lead.
Okay. And
but I would say lead is more like a trace element, so maybe we cannot do on this device quantification, but there is another device where we can, it's much more advanced device of this technique, so we can do quantification and then find out. But do real quantification, you need to have a known material with known composition of same elements. We can do calibration, so we know that amount of, let's say, lead is X%, so we could do a calibration curve, and based on that, we can even quantify. But then just based on this peak intensities, those are very small quantities.
Okay, so there's some lead. Maybe it's a safe amount, maybe not. To figure out, we would have to do some more detailed testing. I think for now I'll play it on the safe side. I mean, Nick, do you wanna drink anything out of my partially lead containing pewter thing?
I'm good actually.
Okay, cool.
Okay, so now, so we can save this data.
Cool, thanks.
The,
Can you send that to me too? I'm really excited to have the data. I love data. I get to look at spectra too, but they don't look at all like this. So to figure out how much lead is in this thing, oh, can I remove this from the stage?
yes.
Okay. So to figure out how much lead is in this thing, one possible experiment that we could do is put together a mixture of the things that are in it, some copper, tin, and lead in some proportion, and then take a spectrum. And then we'd probably have to prepare a lot of different samples where we have really well-known exact mixtures of all the different things that are within this to figure out what's the mixture that makes the exact same spectrum that we just saw. So that's one way to do it. That sounds pretty time intensive. I think there are also some other experiments that we could do that might or might not be destructive, that would actually take a small amount of this and analyze what fraction of the atoms in a small sample are tin versus copper versus lead. All right, so now we know this has trace amounts of lead. We don't know exactly how much. My students don't want to drink out of it. So that's science for you.
As the question is now, is there lead in the teapot?
Yeah, is there lead in the teapot? Yeah, so that's a good question. Ah. I think there's actually some trace water in this teapot still. Of course, water is a molecule, right, made of two elements, hydrogen and oxygen. But both of those are lighter than sodium, so they would not show up with this technique. But can we pour a little into my hand? All right, got some water there. All right, try not to muck up the lab too much. So yeah, this teapot was made, it says it is Forbes Silver, CC or CG USA Quadra something. It's pretty faded. But whatever this is, it claims to be silver. So now we're going to find out, is this teapot really silver? Does it have any elements other than silver added to make an alloy? And does it have any lead in it?
Okay, we're ready. So
We're ready. Cool.
How we can fix it here.
I think I've drank creamer out of that lead-containing thing once or twice. And I'm not dead yet, but I might be crazy. So I think you're making a smart decision, not drinking out of things with lead.
Okay, let's do different ways.
Oh,
I
okay.
want to start, so we can do this way.
Okay. Or I could grab a different thing from the same set. Hopefully they're all made out of the same elemental
So,
admixture.
if you can hold this
Oh,
for a second
yes!
like this.
I get to hold it?
Yep.
Cool. Okay. Do I pull a trigger?
No,
Oh,
I
okay.
would do it from
Okay,
computer.
so I just hold
you
it.
just hold it as close as you can.
Okay, and still.
Just still for 10 seconds. So I'm starting. Okay. This is signal now. Let's wait a few more seconds. And okay. So we
All
can
right.
put it back.
Okay, thanks. I got to hold an X-ray gun. That's kind of cool. I've literally held a ray gun now.
Okay. So now we have a spectra for this. So then we can.
Hey,
go
that looks
ahead.
like tin again.
So that might be silver.
Oh, that would be silver?
Yeah. So
Oh, I
might
can't
be.
see the axis. I'm having trouble reading.
Let me put the numbers here. So we definitely have copper,
Okay.
which is supposed to be there. And then we go to, we have some zinc.
Some zinc. Okay.
The nickel still comes from that device.
Okay.
It's not there. So let me check the silver. Yeah, this
All
is
right.
1 for silver. This is K line, and then this is L line. So we definitely have.
Okay.
It's a pure silver,
Mm-hmm.
and we can add. So those two peaks are silver.
Okay.
Now, most likely we have zinc, small quantity. Okay. Now we can try to look for lead.
Is that the lead?
There is very small amount.
All right. Now we know. Well, I guess we're not going to be drinking
I
tea
think
out of
that
this.
should be okay even because that's really small quantity. If we want to do another test, so we can do with another device and quantify it, but not this one. These might have very small quantities of that.
Okay. All right. Well, thank you so much. I think that answers our question for today, which was, does my teapot have lead in it? The answer is yes, a super, super tiny trace amount. We don't know exactly how much. We'd have to do a follow-up experiment. So, Nick, do you wanna go have some tea later?
I'll pass.
Okay.
Well, until we go on a
I think it will be safe, but but because the amount, probably whatever they make silver contains some tiny amount of lead, which is there. So if you do it very deeper, maybe in all materials, you will find some amount of stuff that shouldn't be there, but it comes as a raw material. So yeah,
All right.
there might be. I would not say in conclusive. There might be some lead. Definitely, it's much less than this one,
Uh-huh.
but you know, it might have some.
Because that was a shallower peak. Okay.
It's more less intense.
Yeah. And we had about the same exposure time on both of them.
So
Okay.
about 10 seconds or so.
All right. Sounds
Well, we
good.
can do. We have a smaller than this piece,
Yeah.
so we can do it more convenient. We can put in a benchtop device.
Uh-huh.
We can run like a little bit longer and then try to compare them. So if that's two metals, two three metals, so actually we can maybe get away without calibration. So based on excluding any light elements, it should not contain any light elements. So we can.
That would be
you know,
pretty striking. Although it might be like, I guess the silver is oxidized a little bit.
Yeah, that surface X-rays penetrate much deeper.
Okay.
So here you might have some chlorine, some oxide, oxygen. We won't be able to see it, but we don't see much chlorine here. So
Okay.
chlorine is another corrosion product of silver. it captures chlorine from air, and the oxide sulfur usually gets in there, so we can quickly check if the sulfur is here. And tiny amount of sulfur, yes,
Okay.
which is normal. So
All right. So we have this pot, which is mostly silver,
Copper.
a little bit of copper, and then does have trace amounts of lead, possibly from the manufacturing process of the silver.
or
Not,
source of the silver.
yeah, not necessarily because they intended to put lead into it. And we would have to do follow-up experiments to figure out if that trace amount of lead is, say, compliant with food safety rules. Until then, Nick will be drinking his tea elsewhere.
Yes.
All right. Thank you so much.